Hello friends, welcome back. Today we will see the last part of the unit number 5. This is some part is given theories of elastic failure. Actually, what is meant by theories of elastic failure? We have seen in the tensile test there is a yield point load can be easily detected. But what happened in the most of the machine element subjected to the complex stresses, it is very difficult to find out the yield point. Okay, so that's why to improve the design of machine element, various theories are developed. Okay, various theories of failure developed based on the physical behavior of the different types of the material. Okay, in each theory there is a relationship between the principal stresses and failure stresses, okay, induced in the material. Okay, so we want to study the theories of elastic failure. There are different theories are given. Okay, for example, we have seen the maximum principal stress theory. So they have given the maximum principal strain theory, then maximum shear stress theory, maximum distortion energy theory, then maximum again you have given the normal stress theory. There are different theories are given. Sometimes in the examination that principal stresses you will get the or question from the theories of elastic failure. Very simple. Here also you have to remember the some formulae. With the help of that formulae, you have to solve the given numerical. Okay, I have not write here formulae. We will solve the directly numerical. With the help of that numerical, you should remember the formulas. Okay. See, first you have given first numerical. We will see you have given the stress induced in the critical point in a machine component. Okay, the steel component is given and stress is induced. The sigma x is equal to 100 Newton per mm square, sigma y is equal to 40 Newton per mm square, and shear stress is induced 80 Newton per mm square. Then we want to find out the factor of safety by given the different theories. First is a maximum shear stress theory, second maximum normal distribution normal stress theory, and third is a maximum distortion energy theory. Okay, a theory of elastic failure is given. We want to calculate the safe value of the factor of safety. Then how to calculate? Here we want to assume the yield stress is given, sigma yt is equal to 380 Newton per mm square. Then how to calculate this? First we know that how to calculate the normal stress, right? We know the calculate the normal stress, because each and every theory we want to calculate the value of major principal stress as well as minor principal stress. We have seen how to calculate the major principal stress and minor principal stress. We know that formula. I will write here. This first is a sigma m is equal to, we will calculate here, sigma m is equal to what? Anybody? Sigma x plus sigma y divided by 2 plus or minus, okay, plus or minus root of sigma x minus sigma y divided by 2 bracket square plus tau xy square is there. Okay, you should remember this formula and you calculate the normal stress or major principal stress as well as minor principal stress. I will put all the value in that equation. Check that what is the value of sigma. 100 is there, plus 40 sigma y divided by 2 plus or minus root of again 100 minus 40 divided by 2 bracket square plus What is the value of tau xy? 80. 80 square is there. If you have solved this equation, then see you will get this value is a 70. 140 divided by 70 plus or minus this root value you will get the 85.44. Okay, you will get this value 70 plus or minus 85.44. Then I will write here is a sigma n1. What is the sigma n1? It is the major principal stress is equal to what you will get 70 plus 85.44. You will get 155 point. If you have calculated, then 44 Newton per mm square. Okay, you will get this value. And what is the sigma n2? Sigma n2 is nothing but 70 minus. Okay, it is the minor principal stress. 70 minus 85.44. You will get the minus value because this value is bigger than this value. You will get the minus 15.44 Newton per mm square. These two values are very important. If you have given the numerical on theories of elastic failure, then definitely you want to calculate first major and minor principal stress. Once you have calculated the major principal stress and minor principal stress, then come to this point. We want to find out the factor of safety by the maximum shear stress theory. Maximum shear stress theory. Okay, what is the maximum shear stress? We want to calculate both way. First, tau max, maximum shear stress is equal to sigma n1 minus sigma n2 divided by 2. Half of that. Okay, it is the tau max is equal to what is the value sigma n1? 155.44. Then c minus as it is, but this value is also minus. I will write in bracket 14.44 15.44 divided by 2. You will get the tau max is equal to, if you have calculated this value, you will get the 85.44 Newton per mm square. Okay, you will get the tau max value is 85.44 Newton per mm square. Then we can calculate the first answer. See, first is a maximum shear stress. I will write here maximum shear stress theory. Okay, how to calculate that maximum shear stress theory? You can calculate the factor of safety by maximum shear stress theory. There are two methods. First is a C. I will write sigma n1 minus sigma n2 is equal to sigma yt divided by factor of safety. Sigma yt divided by factor of safety. Remember this formula. Sigma n1 minus sigma n2 is equal to sigma yt divided by factor of safety. We want to calculate the factor of safety. And how to calculate? We know that sigma n1 minus sigma n2. We will calculate that. Another method you can use this formula. Tau max is equal to sigma yt divided by 2 factor of safety. Okay, with the help of this formula again you will get the same answer. What is the tau max here? Check that. I have written the same. Tau max means what? Sigma n1 minus sigma n2 divided by 2. I have shifted that side 2. Right? Then you will get the same formula. Don't confuse. Okay, different books you have given the different formulas. You should remember any one formula. Sigma n1 minus sigma n2 is equal to sigma yt divided by factor of safety. We want to calculate the factor of safety. Then you will get the sigma yt divided by sigma n1 minus sigma n2. And put the value. What is the sigma yt? Yield stress is given 380. What is the value of sigma n1 minus sigma n2? Check that this value. 155.44 minus 15.44 if you have calculated that factor of safety with the help of both, then you will get the 2.22. Okay, this is your first answer. All of you get it? Very simple. You should remember the formula only. Okay. And then next we want to calculate second one, factor of safety by maximum normal stress theory. Okay, factor of safety by maximum normal stress theory. What is the normal stress theory? Yes, anybody? Factor of safety by normal stress theory. See, factor of safety by normal stress theory, we know the sigma L1 is equal to sigma YT yield stress divided by FOS. Yield stress divided by FOS. We know the sigma N value, right? And we want to calculate here also factor of safety for maximum principal stress theory, maximum principal stress theory and minimum principal stress theory, and we want to choose the one better value. Then what is the value of sigma N1? Check that, 155.44. I will write here factor of safety is equal to sigma YT divided by sigma N1. Then you will get the factor of safety for maximum principal stress theory. What is the value? 380 divided by, what is the sigma N1? 155.44. You will get this value is a 2.445. 2.445. And similar way you have to calculate the factor of safety by minimum principal stress. I will write here sigma N2 sigma YT divided by factor of safety. Okay, what is the sigma N2? Minus 15.44. Then factor of safety is equal to, again I will write directly, sigma YT 380 divided by, what is the value of this? Minus 15.44. This is the minimum principal stress. Okay, then you will get something 24.61. 24.61 factor of safety. Then you should remember first, according to the normal stress theory, material will fail due to the tension. Here we will get the negative value. Okay, if you are using the mod, then you will get the positive value. But according to the normal stress theory, this this material will fail due to the tension. That's why we want to choose the least value out of this two value. Okay, out of this two value, I will write here, erase this one. Okay, all of you getting how to solve? Only you have to put the value. If you know the formula, then directly you should put the value. Then here you will get the factor of safety FOS is equal to this 2.445. Okay, all of you getting the reason? We will consider the tension value. Okay, according to the normal stress theory, material will fail due to the tension, not compression. Negative value is there. And last is maximum distortion energy theory. Third is a maximum distortion energy theory. Okay, maximum distortion energy theory. How to calculate that factor of safety for the maximum distortion energy theory? You should remember the formula, sigma N1 plus sigma N2 square minus sigma N1 into sigma N2 is equal to sigma YT divided by factor of safety bracket square. Okay, you should remember this formula, sigma N1 square plus sigma N2 square minus sigma N1 into sigma N2 is equal to sigma YT divided by factor of safety square. Okay, then put the value. What is the sigma N1? 55.44 square plus, okay, as it is, then sigma into is minus 15.44 square minus, what is the value of sigma n1? Again sigma n1 is 155.44 into sigma n2 minus 15.44 is equal to, what is the sigma y is 380 divided by factor of safety. We want to calculate this value. If you have solved this equation, then you will get the factor of safety is equal to 2.32. Okay, this is your third answer. Sometimes that this type of question you will ask from the 13 marks. Sometimes you will get the 7 marks. Okay, all of you getting how to solve this first numerical? Very simple. If you know the formulae and these two values, sigma n1 and sigma n2, then easily you can calculate. Then similar way we will see the second numerical. What is the second numerical? See, you have given the force. Okay, the force is applied. There is a one pull is given, tensile or positive pull is given on the beam. Check that. This axial pull is given 20 kilonewton. I have converted into the newton, 20 into 10 raised to 3 newton. Then the with shear force is given 15 kilonewton. Okay, then 15 into 10 raised to 3 newton. With circular diameter is given. Okay, diameter of the this circular shaft having the 20 mm diameter, and the yield point of that specimen is given. Yield stress is induced. Okay, from this specimen is a 230 MPa, and they have given the Poisson's ratio 0.3. Then we want to determine the factor of safety by maximum shear stress theory, then second maximum strain energy theory, then maximum principal strain energy theory, and maximum shear strain energy theory. We want to apply these four theories or find out the factor of safety by that four theories. Then how to find out that? Again we want to find out the normal stresses. Okay, major principal stress as well as minor principal stress. Then after that maximum shear stress theory we will find out. But before going on that, see, we want to require which value? Sigma value. Okay, we want to calculate the normal stress. How to calculate that sigma value? Yes, simple stress. How to calculate? You know the stress is equal to P by A. But we don't know the area. They have given the diameter. With the help of that diameter, we will calculate the area. Area is equal to pi by 4 into d square. Okay, put the value of d. D is given 20. Then how much you will get? Yes, check that. If you are doing the calculation, then you will get the 314.16 mm square is there. What is the unit of area? Mm square. You will get the area. Then similarly, what we require? Stress. How to calculate? Again P by A. They have given the pull is given. Okay, force is given. 20 into 10 raised to 3 is there. Divided by what is the area? 314.16. Okay, if you have calculated this, then you will get the 63.66 Newton per mm square. Then check that again. We require the tau. Shear stress is given. Shear force is given. With the help of that shear force, we can calculate the shear stress. S upon A. Okay, 15 into 10 raised to 3 divided by what? Again 314.16. Okay, if you are doing this calculation, then you will get the 47.75 Newton per mm square. Once you know the simple stress and shear stress, then easily you can calculate the normal stress. Okay, this is the sigma n is equal to, you know the formula. Here is a, you don't given the x and y, stress acting in x direction and y direction. Okay, only you have given the stress is uniaxial direction. That's why what is the generalized formula? You know that sigma x plus sigma y divided by 2 plus or minus root of sigma x minus sigma y divided by 2 bracket square plus tau square. Okay, remember this formula. This is very important. Already we have seen. But here sigma y is not given. This is only given for the uniaxial direction. Okay, that's why we consider any one. Sigma x by 2, then you will get the general simplification of that formula. Sigma x by 2 plus or minus root of sigma x by 2 bracket square plus tau square. Take that this formula. Then we will put the value in this equation. Check that. What is the value of sigma x? We have calculated this 63.66 divided by 2 plus or minus root of 63.66 divided by 2 bracket square plus tau square. What is the value of tau? We have calculated 47.75 square. Okay, if you have calculated this two value, then you will get the this one 31 point. If you have calculated 63.66 divided by 2, 31.83 plus or minus, if you have calculated this one, you will get the 57.38. Means if you have calculated, then sigma n1 is equal to 31.83 plus 57.38. How much you will get? 31.83. You will get the 89.21 Newton per mm square. Okay. And what is the value of sigma n2? Minor principal stress 31.83 minus 57.38. Again check that this value is bigger than this. That's why you will get the negative value. This value is a minus 25.55 Newton per mm square. Okay, all of you getting? You can understand this. Say first we want to calculate sigma n1 and sigma n2 value. Then after that you will go to the next. The next is we want to calculate the tau max. Tau max is equal to, you know that if you have calculated sigma n1 and sigma n2, easily you can calculate the tau max value. This put this value sigma n1 minus sigma n2 divided by 2 means 89.21 minus 25.55 divided by 2 is there. Then what is the value of tau max? Check that. 57.38. Tau max is equal to 57.38 Newton per mm square. This value is very important. Okay. Once you have calculated that, then say I will write here some value. Sigma n1 is equal to 89.21. Sigma n2 is equal to minus 25.55 and tau max is equal to 57.38. We require this value. That's why I have written. Okay. Then once you have calculated all this, then check that what we want to calculate. Yes, anybody? First, what we want to calculate? Find factor of safety by maximum shear stress theory. Find factor of safety by maximum shear stress theory. Maximum shear stress theory. Yes, we have seen before that numerical, right? what is the maximum shear stress theory for the factor of safety? Tau max is equal to, tau max is less than or equal to, remember that, tau yp divided by factor of safety. Again I will simplify that. Tau yp is less than or equal to that sigma yp divided by 2 factor of safety. Factor of safety. We have seen the factor of safety. This sigma yp value is given. Sigma yp value is given. Yes, we want to calculate the factor of safety. Then again I will write factor of safety is equal to, check that, sigma yp divided by 2 tau max. Okay, what is the value of sigma yp? This value is given 230 MPa divided by 2 into 1 tau max, 57.38. And what you will get the factor of safety? You will get the 2. If you have calculated, then you will get the factor of safety is 2. This is your first answer. Then what is the second? Factor of safety by maximum strain energy theory. Maximum strain energy theory. Factor of safety by maximum strain energy theory. Factor of safety by maximum strain energy theory. This one, second one. Okay. What is this? Sigma N1 square plus sigma N2 square minus 2 mu into sigma N1 into sigma N2. Check that. You should remember the formula. Sigma N1 square plus sigma N2 square minus 2 mu into sigma N1 into sigma N2 is equal to sigma yt divided by factor of safety bracket square. Okay. Here you have to put the value in this equation. What is the sigma N1? 89.21 plus, here again we have the minus value, 25.55 square, then again this one square, minus 2 mu. What is the Poisson's ratio value? 0.3. Again, what is the sigma N1? Check that. 89.21 into, then I will write in bracket, minus 25.55 is equal to, what is the sigma yt? 230 divided by factor of safety square. Check that. If you have put all this value in that equation, then you will get factor of safety is equal to 2.306. Okay, this is your second answer. Maximum strain energy theory. Then see, there is a wording is changed. If the wording is changed, then again formula will change. Maximum principal strain energy theory. This is the maximum strain energy theory. All of you ready? The next one is a maximum principal strain energy theory. Only you have to put the value in the formulas. Third is the maximum principal strain energy theory. Maximum principal strain energy theory. Third one, maximum principal strain energy theory. Strain, it is related to the maximum principal strain. It is denoted by the Emax. Emax is equal to, we can write EYP divided by factor of safety. Again, Emax is equal to, we know that we have seen the member is subjected to the uniaxial, biaxial, triaxial. We have seen in that how to calculate that sigma 1 upon E minus mu into sigma 2 upon E is equal to sigma yp means again EYP means again what? E means what? E is equal to sigma by E. We have seen in the first unit. E is equal to, we can write sigma by E. Sigma by E divided by factor of safety. This E get cancelled. Check that. We have taken the common, that E, this E get cancelled and you will get sigma 1 minus sigma 2 is equal to sigma upon factor of safety, sigma yp upon factor of safety. Okay, this formula you will get. Then put the value here. What is the sigma 1 means what? Sigma n1, remember that. And sigma 2 means sigma n2. Then again 89.21 minus mu 0.3 is given, minus 25.55 is equal to what is the sigma yt? 230 divided by factor of safety. Okay, we want to calculate that value, then you will get the 2.37. Factor of safety is a 2.37. This is your maximum principal strain energy theory. And last is a maximum shear strain energy theory. Last is a, you will see, maximum shear stress energy theory. Shear strain. Okay, all of you getting? Yes. Maximum shear strain energy theory. Last is a maximum shear strain energy theory. Maximum shear strain energy theory. Okay, shear strain energy theory, maximum shear strain energy theory. See, you should remember the formula 1/2 into summation of sigma 1 minus sigma 2 bracket square is equal to, you have given the sigma yt divided by factor of safety. Okay, this formula you should remember that sigma yt divided by factor of safety bracket square is there. Okay, here is the summation of that sigma 1 and sigma 2. I will again simplify that. 1/2 into, I will write in sigma 1 minus sigma 2 bracket square plus sigma 2 minus sigma 3 bracket square plus sigma 3 minus sigma 1 bracket square bracket complete is equal to sigma yt divided by factor of safety bracket square. Okay, simplify that. Summation of sigma 1 minus sigma 2 bracket square means what? This one. Okay, again I will put the value 1/2. What is the sigma 1? This is the 89.21 is there, minus, then again sigma 2 value minus 25.55. This bracket square is there, plus sigma 2, we don't have the sigma 3 value, put the 0. What is the sigma 2 value? Minus 25.55 bracket square, then plus, again check that we don't have the sigma 3, then again minus. Okay, this minus as it is, again we have the minus value, minus 25.50, we have the plus value 89.21 bracket square. Okay, is equal to, the sigma yt is equal to 230 divided by factor of safety bracket square. Then what is the value? If you solve all this equation, then you will get the 2.208. This is the factor of safety. Okay, this type of numerical will ask for the examination. Remember that if you have taken the tensile test, then there is a yield point load can be easily determined, but some cases it is very difficult in the machine element subjected to the complex type of the stresses. Okay, it is difficult to the know the yield point. That's why we want to use the theory of elastic failure. Sometimes you will get the elliptic shape, sometimes you will get the rectangular, sometimes you will get the square shape of that theories. Okay, that's why this equation will be generated. Okay, today we'll stop here. We have completed the unit number 5, and unit number 6 you have given the application base, means whatever maybe you have learned from the unit number 1 to unit number 5, that application based numerical is given in the unit number 5. Almost we have completed the syllabus, but I will take the again some numericals from the unit number 6. Okay, today we'll stop here. Thank you.